Hey guys, this is our part two for Law of Sines. Just wanted to give you guys a little bit extra practice, a little bit extra um, problems that you can see worked through. Oops, sorry. Um, Let me get my pen working. I feel like every single time it doesn't want to work. Let's try that again. Hey, there we go. So, it's going to give you three more examples, three more problems worked through, and should be one of each. One single solution, one double solution, one no solution. I think that's how I chose these. So, let's jump right into it. Solve the triangle given the information below. So we have two angles and a side. So remember, you want to draw these out, label them accordingly. Um, Try and draw it to where it kind of makes sense. So angle A is 130 degrees. This one looks like an obtuse, so I'm going to put it there. Angle B is 11 degrees. I'm going to put it there since that's pretty small. And A is 28. So what I need is little b, big C, little c. Okay, so I'm going to put that up here. I need little b, little c, big C. And I should be able to find that third angle really quickly since I have the other two angles. So for big C, I'm going to take 180 minus 130 minus 11, and that gives us, let me use my calculator, 180 minus 130 minus 11 is 39 degrees. So 39 degrees. Now, I kind of jumped ahead. Um, Remember that there are certain types of setups that you have to worry about extra solutions or no solutions. This is not one of those because we have two angles and a side. So remember, AAS has a guaranteed solution. You don't have to worry about the what we call the ambiguous solutions. So one answer and it works. All right, so we have big C. Now I'm going to set up the law of sines. And let's see, I'm just going to set it all up. So little a over sine A equals little b over sine big B equals little c over sine big C. So I have one fraction that's just a number, and the other two fractions have a variable. So I'm going to set up those equations with the fraction that just has numbers. So b over sine 11 equals 28 over sine 130. So multiply both sides by sine 11, and we should get our answer. So let me pull out my calculator. 28 times sine 11 divided by sine 130. I get little b is 6.97. So there you go. Same thing with little c. Little c over sine big C equals 28 over sine 130. And multiply both sides by sine 39. And I get an answer. So 28 times sine 39 divided by sine 130. And I get 23.00. And there are my missing measurements. Okay. Remember, if you're given 3, you should be solving for 3. Because triangle has 6 measurements, 3 sides, 3 angles. All right. Let's go on to the next one. So, same instructions, different setup. Angle B is 154, angle A, or sorry, side A is 25, side B is 23. Let's draw this out. So big B, 154, side little b is 23, and then A, doesn't matter which one, I'll choose this one for A, is 25, so big A, big C, little c. So this one is a side-side angle situation because I have two sides and then an exterior angle, which means this one has a possibility of being no solutions. So, or two solutions. So let's see what happens. Um, I cannot start with the subtracting from 180 because I only have one angle. And so I'm just going to jump straight into the law of sines. Notice that B, I have both B's. So I'm going to do sine 154 over 23 equals, and then I have little a, so I'm going to solve for big A. Sine big A over 25. Multiply both sides by 25, and then cancel out the sine by doing inverse sine. And inverse sine of that will tell us if we have an answer or not. So 25 times sine 154 divided by 23, I get an answer, which means we have at least one answer. So I get A is 28.5 degrees. Hold on just a second. Sorry. Dog walked into the room, so I had to shut the door. So I've got my A, and let's see if we have another potential answer. So A being 28.5 is one potential answer. To find the other one, let's do a 180 minus 28.5. And I get 151.5 degrees is our other potential answer. There's a problem with that. This angle cannot be 151.5 because this one's already 154. There's not enough room for another big angle like that because they have to add up to 180. So this over here is a non-answer. Okay, so we don't need to go down that second path. So I'm just going to go down this first path. So now I've got angle A is 28.5, angle B is 154, therefore I can figure out angle C is 180 minus 28.5 minus 154. And I get 2.5 degrees. Little tiny angle. So 2.5 degrees. So there's two of my three pieces of missing information. We know it's going to be one solution, not two, and not zero, because we didn't get an error. So now I have two angles, and I have a missing side. I still need C. So C over sine big C. Oops. And then I can go with either the A or the B fraction. Let's just go with B. And that's going to be 23 over sine 154. Multiply both sides by sine 2.5, and I have my final answer. And I get little c is 2.28, so let's say 2.3. So there you go. That was the side-side angle, the ambiguous case. Wound up with one solution because the second did not work. All right. Let's try one more, and then hopefully that's some decent examples for you to work off of. Angle C is 18, B is 25, C is 10. So let's see what happens. So C is 18. This looks like a small angle, 18 degrees. Little c is 10, B is 25. Let's put that over here. So I still need big A, big B, little a. Okay. So once again, it's side-side angle. So let's see what happens. Okay. I know I have big C and little c, so I'm going to set it up sine 18 degrees over 10. And I have little b, but not big B, so sine big B over 25. I'm not dealing with the a fraction because, just to throw it out over here, sine a over a, that's got two variables, that's not solvable. So you wouldn't have done that one anyways. So over here, multiply by 25, both sides to cancel that out. Cancel out the sine with inverse sine. So inverse sine, 25 times sine 18 divided by 10, and I get 50.6 degrees for B. Okay, 50.6. That means there's at least one solution. There might be two, but there's definitely not none. Okay, so one potential answer has 50.6. The other one has 180 minus 50.6, which is 129.4 degrees. Now, you might not be sure if that works. So on both of these, let's go ahead and solve for our third angle. So 180 minus the two angles I know. Gives me a positive angle, so that one is a potential. Over here, 180 minus the two angles I know, sorry, so 18 minus 129.4. So 180 minus 18 minus 129.4 gives me a positive angle. So both the solutions are potentials, which means I have to do the same exact last step on both of them to find the last missing side. And then I'll have my two possibilities. So let's see. Over here, so in both of them I still need little a. So I'm just going to step a fraction, little a over sine big A, which is 111.4 equals, and I've got b and little b, so let's go with that. Or even c and little c, so how about c and little c? 10 over sine 18. Multiply both sides by sine 111.4. And I get 10 times sine 111.4 divided by sine 18. So I get a potential 30.12. So let's say 30.1 is our side. So these three answers, let me use a different color, all belong to the same solution. So that's one solution. The other one, let's finish solving this one. The only difference is going to be our angle A. So in the first answer, angle A was 111.4. This one's 32.6. So I'm going to try and cram it in here pretty small. A over sine 32.6 equals 10 over sine 18. And multiply by sine 32.6. So 10 times sine 32.6 divided by sine 18 gives me a little a as 17.4. So that is my other potential solution. So two solutions, we found them both. Okay. As long as you can find one, okay, you're doing just fine. But try to find the second if it exists. Remember, you only have to worry about that in side-side angle. So hopefully that gives you a bit more guidance. Okay. Try some more problems for law of sines. I believe this lesson quiz is just saying how many solutions it has. So only go far enough to figure out how many solutions, and then that's it. Okay, you don't have to worry about going further than that. So, hope you guys are doing well, staying safe, and I'll see you in the next videos, and hopefully see some of you guys on the office hours Thursday or Friday, which I'll send out an email reminding about those as well. So, that is it for now. See you on the